What do you think? Should I go ahead and get started? All right, welcome everyone to Best Practices for Submitting Batch Jobs on Oscar. I'm going to assume that none of you, so does everybody here have an account on Oscar? Has everybody here used Oscar, more or less? Okay, so you have some familiarity. I'm going to go over the introductory material relatively quickly then, and we can talk more about the best practices, hopefully. Have people here actually, raise your hand if you've submitted a batch job on Oscar? Okay, so only about half the crowd. Okay, so Jocelyn's excited. So we've got that going for us. That's good. So overview of a presentation. We're going to start out with talking about the job queue on Oscar and how that actually functions, what that means. And then how do you actually create and submit jobs to the queue on Oscar? Once you've submitted a job, how do you check on the status of the job? Is it actually running? If it's not running, did it end successfully? Did it complete successfully, or did it bomb out for some reason? If it's not running, is there a reason that it's not running? And then we're going to talk a little bit about best practices, how to create a batch script. And this is a little more subjective, but I've run it by the other members, like the Res Tech Services team and the systems team, and they all seem to. We all have the same set of this is the way you should do it in an ideal world. And then finally, tied in with the best practices, one of the best practices that we'll talk about is using the appropriate resources for your job. And we'll get at how different approaches you can take to understanding what the best resources, what resources you actually need for your job and how to get them. Please interrupt me as I go. Otherwise, I'll just talk. And this is just slides. I don't have any live demo or anything. I do link to, I've got a GitHub repo. I will show you along the way with the URL that has some example batch scripts that you can go and use as templates for yourself later on. So by way of introduction, you guys all know what Oscar is. Oscar is available to everybody. What you may or may not know is that Slurm, when we talk about Oscar and submitting jobs, we talk about this thing called Slurm. Slurm is the resource manager. Sometimes it's called the scheduler or the workload manager on Oscar. And what that means is that if you're going to run a job on Oscar on one of the compute nodes, even if it's just an interact job where you're just getting onto a compute node to run things, you're doing that through Slurm. Slurm is the gatekeeper that is responsible for allocating resources on the machine to individual users. Slurm, incidentally, is, does everybody know what Slurm actually refers to? That's a backronym. It's a backronym, yeah. Slurm is from a cartoon. It's from Futurama, right? It's the Slurm is the drink in Futurama, and then they that's the origin, and it's a backronym, man. So anyway, what does that mean practically speaking? Well, here's a little diagram of Oscar under the hood. Got all your compute stuff over here, all your nodes, GPU nodes, CPU nodes. When you actually access Oscar, you're going to do it through one of what we call our gateway nodes, either open on demand, the gateway node associated with that, or the login node, which is where you go when you SSH in. You don't actually run anything on the gateway nodes, on open on demand or on the login node. What you do is you, from these locations, from either when you first log in, OOD, or the login node, you request resources for your job to get onto the compute node. And that's where Slurm comes in. So Slurm basically sits between the gateway nodes and the compute nodes. Okay, so if you want to get onto the compute node, either interactively or to run your job in the background, you do it using Slurm. Okay, and what Slurm basically does is it plays Tetris. It's a glorified Tetris machine. And you think about it, Slurm's sitting there and it's got all these job requests coming in. Users, you might have 100 users on the system at one time. Everybody wants some different amount of resources to run their job. Slurm has to take all these requests as they're coming in and try to allocate, okay, this job is going to go over here on this node. You're going to go over here on that node, and shuffle everything around to try to get the optimal throughput. Conceptually, the way this works, this is a really simple slide, but we're going to look at this in just 2 dimensions here. Think about this in terms of a job that you submitted. You need to run that on a processor, and the processors on Oscar, we're going to say cores. So These are all this blue line here represents all the cores on Oscar, and this is time, okay? So your Slurm and a job request comes in that requires, half the cores that are available for some chunk of time, okay? Slurm says, okay, great, we're gonna stick you over here. Then another job comes in, and it requires 3/4 of the processors that are required. Well, job 1's already running, so job 2 just gets stuck behind it in the queue. Okay, so job 2 will run once job 1 is completed. If you have a small job that comes in, doesn't need very many cores, doesn't need it for very much time, Slurm will take it and jump it over job 2 in the queue and let it run because there are resources available for that. If it was a small job that lasted for a longer duration, like that, then it wouldn't be able to fit. It doesn't fit here. So even though it doesn't require very many cores, the duration's too long to fit in here. So stick it after job 2. Okay. Job 5 can jump the queue because it's a small job and it'll fit in. Yes. Are these slides somewhere? I can make them available to you. Okay. Cool.
Another question.
Sure.
So the amount of time for each job that needs to be predefined.
Mhm.
The job.
Yep, and we'll talk about exactly what needs to be predefined for the jobs in a minute. But then, so this all makes sense, right? So Slurm's just it's got these things coming in and it's saying, okay, I'm stacking them and I'm trying to stack them in such a way that I can get the most jobs through. So I'm making the most use of the available resources at any given time. We also have this thing on Oscar called condos or priority accounts where you could pay extra and have a special priority. So what happens if you have a job that comes in that's a condo job? Well, condo jobs, you've paid for it, you've got higher priority. These jobs are already this job's already running, this job's already running. Condo job comes in, even though it's coming after job 2 and job 4, it'll jump the line because it has higher priority and pushes everything back down. Now, keep in mind, this is a nice simple plot with just cores and time. Actually, there are a number of other constraints here that makes it a more complicated game of Tetris. You could think of this going into a third dimension where you'd have cores, time, and out this way would be memory, the amount of RAM that you have available. Then on top of that, you've got constraints. This is a GPU job. This is a CPU job. This is a GPU job, but it requires a Titan RTX. This is, and so there are all of these additional constraints and the jobs come flying in all the time. And Slurm is constantly shuffling the jobs to try to make things work. On top of that, there's this thing called fair share built into Slurm, which says that it's a provision that keeps one user from hogging the queue. So as you submit jobs, the base or the default priority of your jobs gets penalized as you go. So if you submit 100 jobs and then somebody else submits a job, that person who hasn't had those 100 jobs sitting there in the queue is going to have a higher priority. So you don't get to monopolize the whole queue. So there's a very complex algorithm that goes into figuring all this out. And when we've asked the Slurm engineers about it, they just kind of say, yeah, you don't want to go into the details of that. Trust us, it works. Okay, so scheduling jobs. In order to schedule a job on Slurm, you need, or on the system, to run any computational job, you basically need 2 things. You need processors to run your jobs on, that actually execute your instructions. So something to execute your instructions and something to store your instructions and your input and output. So in order to actually execute your instructions, you need cores. The computational core is the default, the smallest unit on Oscar for processing power, okay? To store the instructions, you need memory, right? And to store your input and output. And you need those for a certain amount of time, okay? That's the basis of how Slurm makes its job allocations. These are the resources, the fundamental resources that everybody needs. Processing power, memory, and you need that for a certain amount of time so that you can complete your job. So when we talk about scheduling a job on Oscar, you're requesting resources to schedule for that job, to execute that job. These are the resources that we're talking about: cores, memory, for a certain amount of time. And then there are additional constraints like, do you need an accelerator like a GPU? Special constraints on top of that. Okay. And all of this information is what you specify in your batch script when you submit your job. So a batch script is just a recipe for a job. It's a set of instructions for Oscar and for Slurm in particular that lays out what your requirements are in terms of resources. So it says, this is what I need to run my job. And then once I have these resources allocated, here's what you need to do. Here's the job itself. Okay. So it's like the ingredient list and then the actual recipe. Okay. You can break this down into 3 basic components. The top of a batch script is just the header, and you've got your shebang bin bash, just saying that it's a bash script. Okay. And this is just what a comment line looks like. The next part of a batch script is this is where the job information for Slurm goes. This is where you request your resources. So this is all resource requests here, time, nodes, tasks, CPUs per task. So this is cores, memory. And then this is job handling. We'll talk about that a little bit, what to call the job, where to put the input and output files, what to call the input and output, or the output and error files. So this is all information for Slurm. And you can see that the way this works is these are all sbatch commands. Every one of these lines starts with a pound sbatch. Pound, this is a bash shell. So pound means it's a comment. So bash looks at this and says, it's a comment. I don't read this. Okay. Slurm looks at this with the sbatch command. It ignores this because it's just a pound, and it's looking for pound sbatch. It looks for comment lines that are just sbatch to start with. And then it reads all of these in. Okay. Then the final bit is where the actual job takes place. So this is where your actual commands that are going to be executed. So header, resource allocation, what you actually want to do. Okay, that's all it is. One thing I will say, the order that these happen in within the sbatch commands doesn't matter. Okay, within this blue block, you can put them in any order. What you can't do is you can't mix the blue block with the green block. Once you move out of sbatch commands and run an actual command, then Slurm stops looking for any more sbatch directives. And so anything that's after your first actual command, any further sbatch commands will not be recognized by Slurm. So keep all your sbatch commands together right at the top of the file.
Does it throw an error call, or is it?
No, it just ignores it. It treats it as a regular comment. Okay. So breaking this down then, line by line, for this example file, we start off with just declaring that this is a bash script, and there's a comment line. This is a line defining how much time you need for your job, how many nodes you need, and you should always use one node unless you're doing an MPI job. How many tasks per node, and this is a processor, how many processors or MPI tasks on the node, how many CPUs you're going to assign to that task. And then this is the amount of memory per CPU, okay? So in this case, we're asking for, this would be a serial job, right? You're asking for one node with one task per node and one CPU per task. So that's a total of 1 CPUs, 1 core. And you're gonna have 8 GB of memory for that core. And we'll talk about how you change those and why you might change those later. I will also say that there are about 500 different options for ways you could do this. You don't need to do it this way. If you go and look at the online documentation for the sbatch command that Slurm puts out, SCADMD puts out, there are lots of different ways to do this, and there are default values that are sort of baked into the system. Question?
Yeah, what is the difference between a node and a task?
So a task is, for instance, would be an MPI task. It's a distinct computational, a distinct set of computational threads, I guess, processes. And then you assign CPUs for the task. So if you've got one program or the way you would handle this if you had like a Python multiprocessing script would be you'd have one node, one task per node, and then you'd change the number of CPUs per task. Actually, no, sorry, correction. you'd have, say you had 32 threads that you wanted, you'd go 32 tasks per node, 1 CPU per task. Okay, if you're doing OpenMP or something like that, where you've got, you know, you can assign, say, 4 cores to work on a single OpenMP thread, then you could juggle it around that way. Okay. So sometimes that happens in sort of models where you have, for instance, in climate models where you might have an ocean model and a wave model. The wave model is a shared memory parallelized task, right? So you might assign it 32 cores on one node. Yeah, anyway. Down here, we've got the job handling. So the important things, and they're important, but you actually don't need to include them. These are the basics. -J, and then just whatever you want to call it, the name of your job. And that's just for your own reference later when you're looking through your history, your job history. It makes it easy for you to identify what you've been doing. This is how you define where the output and the error files go. So anything that would normally be written to standard out gets dumped into this file here, which would have a .out at the end. Anything that would go to standard error gets dumped to a file .err. You can actually have these both write to the same file if you want. I tend to separate them out just to keep them separate. And what this means here, %x is the substitutes my job name. So whatever. So this would create a file called my job dash, and then %j is your Slurm ID number, your job ID number. So this would create an output file that was like my job dash 1234567.out, and an error file with the same name but with .error for the error. Okay. And then the next thing you do down here, so we've left the blue block here, the sbatch commands. You load your modules, you set up your environment. If you've got a Python virtual environment, you want to activate a Conda environment. If you have modules you want loaded, this is where you do that. Do it first, and then run your commands.
We don't specify an error output file or the error goes to our dash out.
I think the defaults on Oscars, I think that they both get piped to a .out file. So you'll get one Slurm output file that'll be named like slurm.out or something like that. Yeah. Paul.
So I literally didn't know this until like 6 days ago, but you can do this not in a bash script. You can do it like in your Python script. Or I saw someone
Yeah.
put this out in their Julia. Is that considered like? Because I just thought it was curious that I'd never seen that before. Is that considered not a best practice, or is that considered?
It depends on the application. So what some people do, so for instance, with CESM, the climate model, it has its own run script that you run it, and it pulls all the environment variables and creates its own batch script and fires it off that way. And that's standard. So you never actually run a batch script for that. And there's no reason not to do it, other than, the complexity of building a build script on top of everything else, rather than just having something like this. But yeah, you can script this out. You could create a batch script within a Python, have Python write out a batch script. You can actually invoke. So when you actually launch the file, when you run the file, you run the command sbatch, and then your command sbatch, then the batch script name. Yeah, the batch file name. You don't have to. You can just use the sbatch command with a whole bunch of flags on the sbatch command, and then put your command at the end. So you could do it all from just the command line if you really wanted to. Probably not a great idea, sir. So srun is used for MPI based jobs. So that sets up the MPI tasks on the individual allocated cores that ties into the end tasks. SBatch. Even srun is only used inside an SBatch file. You wouldn't, when you run your actual executable, after you have the resources allocated, you use the srun command to say, run this command and make use of MPI, make use of the available tasks for MPI. Okay. I'll show you in a little later on what that looks like. And then, yeah, finally down here, this is just run your, whatever your application is going to be. For those of you who want to see some examples of batch scripts on Oscar, in your home directory, there's a directory called batch_scripts that everybody has access to. You have read access, you don't have write access, but it's full of example batch scripts that you can use as templates. Some of them are older, they're not necessarily well documented or in the best shape, but they'll get you started. I have a GitHub repo with some example batch scripts for Oscar that you can go and grab that are set up a little more formally. And then if you want to see all of the gory details of all the different SBatch options, and there are literally like 500 different flags that you can use to add on to the SBatch command, go see the SkedgeMD, which is the company that makes Slurm, their online documentation, and there are like an endless number of options for you. Okay, so once you have your batch script together, your recipe, then to submit it from the command line in Oscar, all you do is sbatch and then whatever the name of your batch script file is. Okay. You can actually also modify. So if you use sbatch and then you can add flags in front of the file name, and what that does is it will override whatever you had in your batch script. So if I had -n, so say I requested 4 nodes in my batch script for an MPI job, if I ran sbatch -n2, it would only give me 2 nodes because that 2 would override the 4 in the file. Okay, and this is just an example of, it's literally just sbatch and then the name of your script. And the interesting thing that comes out is that it always responds the return from that submitted batch job and then the job ID number. This actually becomes important programmatically if you're doing dependent jobs in Slurm, because you can always just use this number that comes as the output of that command, the sbatch command. It's the 4th column of the output. You can take that, grab it programmatically, and use it to generate subsequent dependent jobs. So that's a more advanced feature of Slurm that we won't cover today. Okay, so a couple of follow-up questions. I have a condo account. How do I submit to it? So the way you do that is there's an sbatch flag, -- account equals, and then whatever your condo name is. And that will submit your job to Oscar and put it within your condo QoS, which means it'll run with a higher priority and larger resources, whatever the resources are that are available to your condo. To check to see if you belong to a condo, you can use this command here, saccount manager, show a soak where user equals, then $user will put your username. And that will show you any condos that you actually are a member of. You have to be explicitly added to a condo. Just because your advisor has a condo, it doesn't mean that you automatically have one. You have to request to be added to it, and your advisor has to approve it. You can see the list of all of the condos that are available on Oscar by using their 2 commands. There's the condo command, which is the old command, older version of the command, and then there's the condos command with an S. The condos command with an S gives you a full breakdown of what the resources are per user, what's available on a per user basis on Oscar within the given condo. And then finally, this is kind of a useful thing if you're submitting to a condo. If you use the command condo and then the name of the condo, you'll see all of the jobs that are that are currently running on Oscar that are associated with that condo, that are tied to that condo. So this often happens. People will submit a bunch of jobs and say, they've been sitting, they aren't running. I don't understand. I've submitted to a condo. I've got all this special access. What's going on? Well, it's because the 23 other people who are in the condo have also submitted 100 jobs each. And so even though Oscar may have extra capacity, your condo may be full up. So that happens.
When that happens, Paul, is it like, would it be advisable to just, have the user just submit like the regular batch?
The batch partition depends on the size of the job, what the resources that they need. Yeah, You can submit to condo partition, and if your condo is full, you can still submit to the regular batch partition or the GPU partition associated with your account. So condo accounts are, so with a priority account, let's start there. Priority account, it's assigned to a specific user. So a user has a priority account. You pay a certain amount per quarter for that. I forget what it is, $200 a quarter, something like that. And that sets the limits on the resources that you can get. So a regular account, what we call an exploratory or free account on Oscar, you get 32 cores for 48 hours. That's the biggest job that you can run. 32 cores times 48 hours, whatever that works out to in terms of CPU hours. Priority account, all that's happening is that you're changing your user limits. And instead of 32 cores for 48 hours, it's like 208 cores for 96 hours. So you can run larger jobs, or you can have more jobs running simultaneously. A condo is, but you can't go beyond that 208 cores. A condo is basically somebody is paid to buy hardware on Oscar, or virtual hardware. And it's shared amongst lab members. So if your PI buys, 4 nodes on Oscar, and then everybody in their lab gets access to those 4 nodes, in theory, your job will run fast, right? If everybody's not using it, you get next to run access on those nodes. But if all of if all of your lab mates are submitting jobs at the same time, you're bumping up against them using those same resources. So every user counts against the condo's resources. You can think of it as a little mini cluster almost. Does that make sense? Okay. Next question that we see, I need a GPU. How do I get one? Well, if you need a GPU, and you need to make sure that your application is actually built to make use of a GPU, because a lot of people try to run on GPU nodes and then their application doesn't need a GPU and the GPU just sits idle. So people who could be using a GPU aren't, because it's taken up by somebody else's job. Anyway, the sbatch command, you actually have to request a particular partition. The GPU nodes are separate from the regular batch partition. So you have to specify in your batch script, there's an sbatch command -p for partition, and then GPU, meaning I want my job to be assigned to the GPU partition. Okay, that puts you onto the GPU node. You also have to have this little flag at the end, --gress equals GPU colon, and then the number of GPUs that you want. So this would be 1 GPU. So it's not enough to just be on the GPU partition. Having a job on the GPU partition doesn't mean that you have a GPU. You need to actually specifically request a GPU or 2 GPUs or 4 GPUs on the partition, or else your job will just be on the CPU on the GPU node. If you have a GPU condo, you wouldn't submit to the GPU partition, you'd submit to whatever your GPU condo is with a condo name there. But the same idea, you have to have this gress GPU flag at the end to actually get the GPU. Okay, what if you have code that requires a particular type of GPU, specific hardware? What do you do then? This works for other things too. You can actually do this with CPUs. You can add a constraint flag to your sbatch file that says, sbatch -- constraint equals, and then the type of GPU that you want. So I need to run on an Ampere, or I need to run on a Volta architecture, or whatever. You put that in to your resource allocation request at the top of your batch script, and that will guarantee that your job will only run on a GPU node that has the particular architecture that you want. To get a list of what the available architectures is, what actual GPUs are available, you can use the command nodes. And under nodes, you can look in the features field. And what that does is it shows you all of the different groups of nodes sort of grouped together by architecture, how similar the hardware is. And it breaks down the different fields on each node. So it'll tell you what the CPU is, what the GPU type is, all that. Anything that's in the feature field, that appears in the feature field, can be used as a constraint. You can also have multiple constraints. You can use Boolean logic within your constraint to say, give me this, it needs to run on this type, or, I need to run on this this architecture, but it needs to have this much memory. All those things are options. Okay. So once your job is running, how do you actually check on it? There are a bunch of different options. We have if the job is actually running or pending, so it's been submitted, but it hasn't completed yet, you can use either the myQ command or the which is just an Oscar command. It's kind of a wrapper for the SQ command. This is the actual slurm command, SQ -U, and then your username. And that'll give you a list of what jobs you have scheduled or pending or running. Once a job is completed, you can use the saccount command, which is the slurm's, it's another slurm command, -U, your username. And then, for instance, you can say, you know, I want to see all the jobs that I ran between February 1st and February 14th this year. So you could do saccount -U, your username, -S is the start date. You put in February 1st, -E is the end date. And it would give you a list of all the job numbers and all the job names and everything associated with that. So that's a way to look at older runs that you've done successfully. When you have a job that's pending and it hasn't run yet, you can ask, well, why isn't my job running? We get this a lot. When you look at the myQ command or myJobInfo command too, you'll see a thing over here that says reason. One of the categories that you get in the table is reason, and it'll show something in parentheses depending on why your job isn't running, if it's sitting in pending. Resources is one thing that sometimes you'll see it says none, which just means we're waiting for, you know, just it's in the process of being scheduled, basically. If you see resources, it means there aren't enough nodes. The resources that you required aren't available right now. So we're waiting until the resources get freed up. Priority means that there are jobs, jobs with a higher priority than you in front of you in the queue. We have to wait for those to clear out. Group CPU limit, group memory limit. These are things you run into with condos, okay? If you see this as a reason on Oscar for your job not starting, that means that all of your condos cores or memory are in use already. So your condo's flat out and they can't take any more at this point. So you're waiting for other people's jobs to flush out of the system. Job held by user, you can actually place a hold on a job yourself, but presumably you'd know that you did that. Requested node not available. So if you ask for a specific node and that node's not available because it's being used by other users or it's offline or otherwise unavailable, you'll get that. Partition node limits, you've requested more nodes than are actually available in the partition. So we don't have those resources. Anyway, this is a way to decode why your job isn't starting. Yeah.
The last two, those will stay in your queue. It'll stay in your queue and
they'll sit there pending, yeah, until you have to cancel them. And that will happen with any, if you ask for 1,000 nodes, or 10,000 cores, you can do that, and the job will just sit there pending, and with a error message saying resources, or something along those lines. Okay.
You said if you requested like a specific node, so why might you request?
You might request a specific node. I don't know, benchmarking. If you wanted to run code in different configurations, but make sure you're using the same hardware and the same everything, so you're for reproducibility. So you're making a nice apples to apples comparison. You might ask for the same node. Maybe you have an affinity, you have a favorite number, node 1123. 1123 is my lucky number. I'm only going to run on node 1120. You can do that, We don't ask why, we just okay, so now we're gotten to the point of the talk where we can talk a little bit about best practices. And this is, after consulting with the user services, res tech services, and the systems group folks, we came up with sort of a, tried to keep it a little bare bones. Use comments. You should do this anyway. If you're writing code, use comments, because you will forget what you did and why you did it. Like the next day, you'll come back and be like, why did I do that? You all know that. This is something that we see that a lot. Don't rely on inheritance. Okay, when you launch a job, that job inherits whatever you happen to have loaded into your environment at the time. Okay, that's great. But if you set up your batch script to rely on a particular module, and then a new version comes out and you're in your .modules file, you load that by default. Suddenly you're not using the same modules when you run your command. So anything that you do in terms of activating a conda environment, activating a virtual environment, any modules that you want loaded, do it explicitly within the batch script so that you know and you can go back, you have that record of this is what I actually used. It's not some guessing game of, oh yeah, I changed my modules file 4 times in the last 6 months and who knows what, but it worked 6 months ago, I swear it worked. We get that, you know, that happens. If at all possible, use checkpoints in your code. Checkpoint your code. For those of you who don't know what checkpointing is, checkpointing basically means that you're writing out temporary restart files so that you can start if the code crashes for some reason, if Oscar goes down for some reason, you've got some intermediate step along the way. You don't have to rerun from the beginning. Okay, some applications have that built into them. The systems team is actually actively in the process of building checkpointing in, it was a DMTCP, which is an application that'll do checkpointing for you, especially if you're doing, you know, if you're doing a run that's going to last an hour or even 24 hours, it's not a big deal. If you're running a molecular dynamics simulation or a climate model where you might need to run for a month, you don't want to risk there being no downtime or nothing going wrong for a month. So try to get that intermediate output along the way so you can restart your run partway through if you can. And then finally, request only the resources that you need for your job. And again, when we're talking about resources, we're talking about nodes and cores, memory, and time. There are 2 reasons for doing this. One is altruistic, right? If you request more resources than you need, then while those resources are assigned to you and you're not using them, they're sitting idle, other people are stuck not being able to use them. So it slows down the throughput on Oscar for everyone. That's the altruistic reason. The more selfish reason is that the more resources you ask for, the longer it's going to take your job to actually be assigned. It'll sit pending longer because it's a bigger piece of the Tetris puzzle. So it needs a bigger space to fit in. So the more you can minimize the resources required, the faster your job will get through pending and start to run. And the happier everybody else is because there are more resources available for everybody else. Okay. But this begs the question, how do you determine what resources you need for a problem? And this is really problematic, actually. There's no good a priori way to know for many applications what you're going to need, certainly not in terms of memory or time. You can make some guesses in terms of CPUs and cores and that sort of thing, nodes and cores. But let's talk about this a little bit. So what resources should I ask for? For nodes and cores, the first thing to ask is your code serial or is it parallelized? And if it's parallelized, how is your code parallelized? Is it threaded? Is it multi-processing? You know, is it shared memory parallelization or is it distributed memory parallelization? Okay. If your code is serial, you should only ever use a single core on a single node. Okay, and that's a remarkably large fraction of the jobs that run on Oscar are serial jobs. Okay. If your code is parallelized, if it's Python code, unless you're using MPI for Pi, it's your shared memory parallelized. Okay, and you should, which means that you're restricted to running on a single node. You need to share. You can have multiple processes going, use multiple cores, but those cores have the same node. Okay, if that's the case, then you should only ever run on one node. Okay, and then if you're running with MPI and you can use multiple nodes, but only under those circumstances, only if you're actually an MPI job should you be running on multiple nodes. What else do I want to say about that? Oh, the other thing is, even if you're parallelized, it's worth keeping in mind that, well, how do you figure out whether or not your code is multiprocessing or parallelized at all? You can look at the code, you can look at the documentation, and that's really the best you can do. And even something that has MPI calls in the code itself, if it wasn't compiled, been built with an MPI compiler, then it's not going to be able to make use of those. So it's more than just looking at the code. It's a little more complicated than that. So how do you actually figure out, beyond going through the documentation or reading it, what do you do? Well, you can test, right? Run your code with a single core, run it with 2 cores, run it with 4 cores, run it with 8 cores. Does it change the runtime at all? If it's not changing the runtime, the extra cores aren't doing you any good. And that's the way to do it. And even if you have a code that's MPI and you can make use of 10,000 cores, there are overheads associated with communication that are going to limit the usability. You're not going to, you might be able to use 1,000 cores, but you'll probably get the same runtime that you would have gotten with 256, something like that. So you should test how well the code performance scales with the amount of resources that you're throwing at it. In terms of how do you actually, what does that mean practically in terms of changes to your batch script? This is the original batch script that I showed you, which is for serial code. Oh, sorry, it's got all these on here still. Okay, if you're going to run something that was shared memory parallel, with shared memory parallelism, something that makes use of pthreads or OpenMP or multiprocessing, what you're going to change is this line here. You're going to change the number of tasks per node, and this will give you the number of cores that you want. Okay, so this would give you 32 cores, right? So 32 cores per node times 1 node. That means you've got 32 cores. 32 cores times 8 gigabytes of memory per core means you've got 256 gigabytes of memory total. Okay, that's how you get at the total resource that you're using. If you had distributed memory parallelism, in addition to changing the number of tasks per node, you change the number of nodes, so you could make use of multiple nodes. And then you would also use the srun command down here to run your application. In this case, hello is the application. And you'd have to use actually srun minus MPI equals PMIX2. That flag is important. It allows for some Slurm integration. And then your command. And in this case, you'd have your total job size would be 32 tasks per node times 4 nodes, which is 128 cores. 32 cores times 8 gigabytes of memory per core. Was it 256 gigabytes per node times 4 nodes is a terabyte of memory. Okay, that's how that works. And this is why I split these out separately too. So in my batch scripts, so that you can very clearly, if it's a multiprocessing job, you just change the number of tasks, right? And nodes is explicitly stated there. So you're only using 1 node if it's serial or multiprocessing. The other things that you can do in terms of looking at your resource allocation with cores, if the job is running, you can SSH onto the node name, the node that it's running on. And then you could run a command like top or nvtop, which will show you the number of all the processes that are running. So if you've asked for 32 cores and you want to see if your job's actually using them, you could SSH into the node that it's running on, run the top command, and if you see, oh, there's only 1 process running, and 31 cores are sitting idle, then you probably don't need 32 cores. There's a caveat with this though, which is that especially if you're doing pipeline type workflows, not everything is going to be parallelized. So you may happen to be looking at it at a time when it's going through a serial cycle, when other parts of it may be parallelized. So it's 1 bit of data, but it's not complete. nvtop is a command for looking at GPUs. So top for CPUs, nvtop will give you the utilization of the CPUs. If a job's actually completed, you can go back and look at this retrospectively using the myjobinfo command or the ceph command. And the ceph command is particularly interesting. So this is the output of myjobinfo, and the format is just myjobinfo minus J and then your job number. And you get all the different steps, Slurm steps associated with this. The important thing here, this is the amount of time that the job lasted. Okay. So if you ask for 24 hours of time for your job and it ran for 1 hour and 15 minutes, you know that in the future, you don't have to ask for 24 hours. You could ask for 2 hours, 4 hours, something like that. So you can reduce your request. The other thing that's interesting is this bit over here. This is the maximum resident set size in units of bytes. Okay. This is how much memory at its maximum, how much memory did your application use? And memory usage will vary over time. This just preserves the maximum. So you can see down here, let's see, that's kilobytes. So that would be what, 9.2 megabytes. So 159 megabytes of memory. And I requested 187 gigabytes. So this was overkill for memory, right? This was not necessary to do. So I could, for this job, ask for a lot less memory and be fine. Okay. Yeah.
On the MPI job, is max RSS across all nodes?
I don't believe so. Yeah, which is part of the problem with it. It's limited. It's imperfect. I should double check on that. I don't think it is, but yeah. This is the other option. Yeah.
So if you like upper request time for the session that's and
Once your job is, if you ask for 24 hours of time and your job's done after 15 minutes, then your resources are released back. After those 15 minutes, those resources are released back to the pool. As soon as your job is completed, the resources return to the pool. Yeah. So yeah, exactly. So a 24, if you're asking for a job that lasts 15 minutes, you'll be scheduled like that. If you're asking for one that lasts, 15 hours, you may have to wait around a few minutes before it actually goes. In practice, the difference in how long it takes is not very much, a couple of minutes for most jobs. But every little bit counts, and there are always these edge cases where something sits pending for a really long time. Another, this is a relatively new feature on Oscar, this thing called CEF. Its command stands for Slurm Efficiency. And the command itself is just CEF and then your job ID number. This is for a job that's been run. And it gives you all sorts of useful information about your job. So worth note here, it's CPU efficiency. So how well did you actually utilize your CPUs? And for this job, I had 9 days, 5 hours and 14 seconds of total wall time because multiple cores on multiple nodes for a given period of time. I only used 3.13% of that available. So a lot of cores were sitting idle for much of the time for this job. Okay, so this suggests, again, I'm not making good use of my CPUs. I should ask for fewer CPUs for this particular job. So yeah, I had 22 nodes, 24 cores per node. So I had 12 cores per node. So I had 24 CPUs in this case, 24 cores. And let's see, memory efficiency. And for this job, 96 gigabytes was requested, 793. This was the max amount of memory that was used. This is the max RSS. So a little less than 1% of the memory is used at max. So again, you could reduce your memory based on that. Yeah.
Is that the state in red?
There are little sirens that go off, and yeah, no, it should be. But yeah, so this is. But these are things that you don't think about. And honestly, for some of this, so this was an example where I was actually, this job was just a test. It was a standard built-in test for an application. And so it was an MPI based application, and it had a whole bunch of serial tests and some MPI tests involved in the test suite. So I just ran it with a couple of, and really it was way overkill but it was a one-time thing. Who knew? If this was something I'd be running again and again and again, this is useful information. You can go back and you can test it and reduce if you're going to be running similar jobs. Okay, in terms of memory, what memory should you ask for your job? And the rule of thumb is the first time you're running a job, ask for a lot, and then see how much you used. And if you didn't use enough, reduce it, in the future. Or if you used more, didn't use what you allocated, much of what you allocated, just reduce it in the future. So be generous the first time out and then cut down after that. If you ever in a situation where you're asking for what you think is a lot of memory and it's not still not running, and you're getting segmentation faults or you're getting out of memory errors, you can always add a line to your batch command, sbatch -mem = 0. This will give you all of the memory on a node, so that your node won't share. No other jobs will run on the node while you're running on it, and you'll have access to all of the memory just sort of you're maxing out the node at that point.
Just remembering, or is there something where like temp is memory?
That is correct. So the temp directory, so the nodes on Oscar are diskless nodes, which means they don't have they don't have a disk associated with them. They only have RAM. So when you're writing files, temporary files and that sort of thing, they'll be written to the /temp directory, and the /temp directory is really just RAM. Okay, and then time, let's see, if you run out of time, your job will be killed. So the first time you run something, ask for a lot of time. You think it's going to run for an hour, ask for a week. You know, you may wait a little longer, but you know, it's always good. You never want to cut it too close. It's like, okay, I've been running and I've run it twice now and it takes about an hour and a half. Don't ask for an hour and a half, ask for like 3 hours. So you've got a little bit of a buffer, because sometimes the file system gets a little slow, or somebody else is running something on the node and it bogs down because you don't have full access to the cache you would like. So give yourself a little bit of a buffer. But again, trial and error is the best way. Questions about any of this? A lot of this is documented in our online documentation. You guys know about contacting Oscar support. And I just want to point out, for those of you who don't know, we have workshops at most Monday afternoons for an hour from 3 to 4 o'clock. These are the ones we have queued up in April. You can sign up. They're all on Zoom. You zoom in for them and zoom out, covering a bunch of different topics. We also have our research computing boot camp. This will be our 3rd annual research computing boot camp, scheduled for June 6th to 9th. So it's 4 days long, coming up, and we'll be making announcements about that shortly. And you can always look at the CCV events calendar online, which has options for signing up for all these things.
Just some best practices with credentials.
For credentials within a batch script?
Yeah, so for example, my job requires a password.
Okay.
Oh, I don't know that I can really speak to that.
That I would say good practice is not to store your password in batch script. That's for sure. If you can set things up so that you can do things without the password, you can set up SSH keys or something like that that would allow you to. Where are you SSHing to and from and within your job? Are you?
Actually, my job actually runs the identity file to copy from files I saw to the software temporarily. So that requires my password. So yeah, I don't. Yeah, that's how.
And you just wanted to automate it in the background, or and then you run once in a while, or?
Yeah, so what I did was write a name and particular so I can just put in but I think I don't pass. Yeah, but I wonder if doing like a batch that job.
Don't know, I'll give you advice on doing passwordless or handling passwords in sort of situation.
It's a pretty weird mistake.
Well, I can say if you wait until June, you won't have to do that anymore, because everything's going to be unmasked and you won't be doing these transitions. Is it going to be only one big giant process? I thought there was going to be like the enterprise fast and our fast. I don't know. Like if it's not that way, it's all literally just one. That feels like it's going to be problematic. You would think, but it's supposed to have. But it's going to be uniform performance across. This is what it's saying. I mean, anyway, we'll see. We'll see. Yeah.
I just have a very general question about, you talked a lot about sort of the different parameters, like from the resource user type, like time, memory, and CPU /codes.
Yeah.
And I'm curious, like in deciding whether to like parallelize things, and that's a big job to tiny jobs. what is like the currently what is like the like resource constraint Oscar response? I guess a concrete example is like, let's say I have a job that takes a lot of memory. I've been running into this issue. It's like I feel like the queuing is, pretty fast on Oscar, but like would it be better to like split it to like say 1 hour each of these like kind of high memory intensive jobs, or can I like wait for the for the queue like allow me to say like it's the longest time.
Depending fairly on the particulars of your use case. Like how much memory is a lot of memory. So you're saying you're submitting a job and you're requesting what, 300 gigabytes? How much memory is a lot?
I mean, yeah, I guess I haven't run into this issue. I guess my prerogative is trying to see if I run into the issue in the future. What's the how do I minimize that viewing time if I want to like my memory?
Yeah, so it's really gonna depend, like, for example, with memory, if you're trying to run a normal node and you're running into resource limitations there, you might want to switch to one of the large memory nodes and request that, and that has its own partition, so you can submit directly to it, and you don't wait in the same queue. So there are, shorter run times, but also shorter wait times. Well, so that's one thing. In general, if you break things up into smaller jobs, it's you have to. There's some trade-off, right? In terms of the actual extra process of breaking the job up, and probably the extra time stitching all the results together versus doing it hard. So you have to evaluate that in that case like this case, how long it's going to do.
It's something when you're like,
yeah, array jobs are very big for dependency. So with an array job, you can write one batch script and have 1,000 copies of itself. Data, set of data.
just one question. So the first one is, according to your experience, how difficult is for users to get this skill back, to write script, to getting into writing the back?
My experience is that it's not that bad. Once you have a template to work off it, you can show user implementation usually in its own module.
At least 70% of it.
Yeah, I think so. It takes 5 minutes of explanation, and if you've got good commenting, and you code,
Are there any metrics to be found?
metrics on
Or people, they copy for them while they being using that.
no, it's entirely adequate.
Yeah. Then my follow-up question would be, is there any like level of application with a UI that will just create your batches instead of you actually design this?
Oh, yes. Open on demand has the functionality of creating a batch. I don't think it's that. But there is a job creator that where you can just go in and through the whole web interface you define this for this extent, this memory, this time. Here's the command online, and it'll create the batch script for you and submit.
You will be seen here,
Well, it depends though, because I think that for the most part, what happens is that this interface is going to be sort of restricted. You're limiting yourself to the basic features that you might not be able to ask for constraints or ask for, or you might have to go through some hoops to be able to figure out how to dependency I've had to look at functionality because again, I know it exists within OD, whether or not that would be I don't know anybody's used it. I've asked folks in the
way up to. Yeah, first one is up, yeah. Okay. Not that I would. I wouldn't mind having a strict constraint to, kind of just like these people that just having a decent product that. Yeah, and condition manager, yeah, there's not a condition manager, people in our. Oh, go to OpenP and see if the. Right,
I've got my computer hooked up. What am I doing? Oh. So it's this job composer feature. And again, we'll see if it actually. So I have not used this, but select a job and click here to open the path. Edit, next. But anyway, so Camilo, if you want to play with this.
My point goes. If teaching people how to go, we were in the 1980s, 1990s, like sit down and write code. Yeah, do everything this stuff, not right. Then you make things in kind of development that in the asset books.
Well, like I said, this is, this is it basically. This is the graphical interface you can go through. I suppose it could. I mean, all it is just to do is spits out a text file, and yeah, it's pretty simple conceptually. You want to put together a GUI and use it.
I'm just asking.
Yeah, I am not aware of one other than this. But then, most users, PC systems, they down if you're using Slurm, for the most part, you're going to do a take coding. Yeah.
For example, the guy that is Kubernetes and biology that has seen started writing their own job, maybe that's what I would say right here is going to be just like a personal, that's there. Yeah.
Right, no, now this user, there's a little bit of work, but it's not. My experience has been that if you give somebody a well-documented batch script template and explain to them, these are the steps that they can do. For the most part, you don't need. I think I'll yeah, people need resources here, and there's no easy way out of them.
Yeah. Okay, kind of good people who often start asking specific questions about and specific part of that.
I would say it's not a common question.
Yeah. Oftentimes what happens is somebody gets a batch script because somebody else in the lab handed it on, and they might be confused because the person did something funky in batch scripts, activating an odd environment, adding paths to getting them. But if you start people scratch, but again, I don't know if this works or how well it works. But it's working.
As always, this, you have to get after this.
I would say that would be essential because you want that. That's like the manifest.
Yeah.
Job to run.
But yeah, it's something like, oh, indeed, that it's just disappearing in ether. Yeah.
I also wonder a little bit philosophically, it makes things customize things so much that people have no beginning.
You're really abstracted.
You're distracted away, and what happens if that person then goes, if that's a PhD, now the new faculty at the university, doesn't have public service, suddenly they can't do any of their work because they were always, given things on fire. So, which is, maybe not a problem to worry about. It's a consideration. Somebody should do it. All right.